Hello everyone, welcome to this video. I hope you guys are doing well. In this video, we are going to discuss numeric data types in Kotlin. As discussed in the overview, data types in Kotlin are very much similar to than that of Java programming language, and reason is very simple. Kotlin is also going to be executed on JVM machine. For that reason, if we consider integer types, we have exactly similar data types than that of Java programming language. So we have byte data type whose range is -128 to +127. We have short data type requires 2 bytes of memory and range of values is -32,768 to +32,767. For int variable type, int data type, memory requirement is 4 bytes and value ranges from -2 raised to 31 to 2 raised to 31 minus 1. Similarly, we have long data type. For this long data type, memory requirement is 8 bytes, that is 64 bits, and minimum value that can be stored is -2 raised to 63 up to 2 raised to 63 minus 1. There is nothing special about data types in Kotlin. When you are already familiar with Java, these are not new for you. But there are some important points to understand about integer literals. So literals are nothing but values in our program which appears and used as it is, right? So for integer literals can be expressed as a decimal value like this. Integer literals, when you want to describe that integer literal as a long type of value, it should end with L character. Integer literals can also be expressed in terms of hexadecimal number. So sometimes hexadecimal numbers, it is useful because it is useful to represent colors, it is useful to represent some uh, encoding strings and all those. So for assigning hexadecimal numbers or expressing hexadecimal literals, it should start with character OX. Kotlin also allows you to express your integer literals in terms of in binary format if you want. For that, your binary number should start with 0B. Additionally, there is one more important point, may not be used very frequently, but you should know. So underscore symbols are allowed in literal values and it helps in increasing the readability of our program. In many other programming languages, octal literals are allowed, but in case of Kotlin, octal literals are not supported. Most important part to understand about integer data types is understanding its literals. So let's go to Android Studio and let's try to understand all these points that we have discussed. Here we go. We are in Android Studio. I will create a new file with name integer literals. In the main function, let's for each of these points, let's try to add practical example. Okay. So first point is if you want to declare a variable as a long type of variable, and if you want to define some initial value for that variable, then it has to be a character L at the end. Okay. For example, val max equal to, if it is going to be a long value and if you want to store a very huge number in it. Okay. So it cannot be if you are not explicitly defining the data type, and if you want to treat this as a long type of value, right now it is being treated as a long, so we should add character L at the end. Okay. Second important point is we can have hexadecimal numbers, hexadecimal literals. For example, I want some red color code. It's long type of variable. So for hexadecimal numbers, we should have, it should start with 0 x. X should be capital. And color codes. So we know that color codes FF, then 3, 4, and 4A, for example. All right. So val, let's say theme color. So theme color is going to be a long type of value, or integer type of value is also fine. So here I am going to write 0x, let's say ed, and 89 and b3. So hexadecimal numbers, both small case characters and uppercase characters are allowed. All right. So this is how we can create, we can have integer literals expressed in terms of hexadecimal numbers as well. Next point is we can describe these integer literals as a binary number. For example, binary number. And binary number, it could be useful if, for example, if you are writing some code which is usually useful for network related operations. So 0b 1010 11010, something like this. So whatever decimal equivalent of this number, that will be stored in this binary number. All right. For example, I want to store a number, let's say uh, 32. So to store the number 32, binary number should be, or let's say 35, 10000011. Yeah. So if I print this number, print ln binary to decimal, if I print it, it will be still considered as a decimal number. This will also be considered, these two will also be considered as, or printed as, decimal number. This is just the representation we are using. So red color, if I print the value of red color equal to dollar red color, it's not going to print it in terms of hexadecimal number. Theme color, it is just for representation purpose, nothing other than that. And now if I run this, you will find that these numbers that we created, these are only used as a representation, okay, for reading purposes, not for any kind of presentation. I mean, while it is being used, it will be used as a integer or long values, whatever it is, but while we are just assigning the value, we are assigning it in terms of hexadecimal and binary. Here we go. So number 35, so this is the decimal equivalent of this number, this is the decimal equivalent of this number, this is the equivalent of this binary number. So this is how we create it. Another important point is, for underscore symbols are allowed in case of uh, whenever you want to assign some very big number. So in that case, underscore symbols are allowed. For example, world population in 2080, it's going to be a long value, for example. And if it is going to be a very big number, you can store it in, you can separate it using underscore symbols. You can store it using underscore symbol like this. Underscore symbols are also allowed for binary numbers. For example, uh, color bits equal to 0b, so 10011100 underscore, that was my first bit followed by second bit, for example 1110 and 0011, and next bit is 101. So this is how we can use underscore symbols in our any number, binary, hexadecimal, integer. Even it is allowed in, uh, hexadecimal numbers and floating point numbers as well. So apart from byte, short, int, and long data type, Kotlin also supports unsigned integer types. It means that we can declare a variable in which we will store only numbers greater than equal to 0. No negative numbers will be stored. Strictly we will store the positive numbers, and there are many scenarios where we have to store positive numbers. Okay, for example, age of a person, price of a product, these are always positive numbers. Quantity, sell quantity, buy quantity, all these are positive numbers. This cannot be negative number. So for that we have UByte data type, UShort, UInt, and ULong. Okay, so ranges are 0 to 255 for byte. For short, it is 0 to 65,535. For UInt, it is from 0 to 2 raised to 32 minus 1. For ULong, it is going to be 0 to 2 raised to 64 minus 1. So when we are using unsigned integer in a binary representation, the one bit that is used for storing the sign of that variable now will be used as a part of data, and hence we have this increase range. To declare our literal values for unsigned variables, unsigned integers, it has to be appended with u, character u. It can be capital U or it can be small u. So let's try to understand it practically with the help of some small example, and let's head towards Android Studio once again. To declare unsigned variable, for example, val, uh, let's say sale quantity, it's going to be UInt type of value or UShort type of value equal to this one, but it has to be end with character U. Either it can be small u or it can be capital U. For example, cell quantity age of a person, it's going to be UByte, and it will be, for example, 45 capital U. You cannot have a variable without, you cannot have unsigned integer without literal U. And even if you say, like, uh, matches, number of matches played by a particular player, it is going to be UShort type of variable, and if you try to store a negative value in it, it is going to show you some error at compile time. All right, so this is how we use u unsigned variables. All right, so unsigned variables are useful to store the zero numbers greater than equal to 0. This is about unsigned variable. Next numeric data type is floating point variables. Same as that of Java, we have float variable, we have double variable, we have float data type, double data type. Float data type requires 4 bytes, that is 32 bits. Double requires 64 bytes, that is 64 bits, that is 8 bytes. All right, so this is the distribution about significant bits, exponent bits, and decimal digits. There is one small point to understand about floating point numbers. So for to store a number of type floating type, if it is a float type of variable, you have to, the float literal has to be appended with character f. Character f is to be appended to indicate it is float type of value. If it is not float type of value, if you do not add that f at the end of this real number, by default Kotlin compiler considers it as double type of value. All right, so let me repeat once again. If you want to initialize a variable and you want to specify a float literal, then it must end with f. If you are not ending it with f, it will be considered as double type of value. All right, so let's try to understand it using Android Studio. So here I'm going to write float and double literals. So first point is float should end with character. Float literal value should end with character f to indicate it is float value. Okay, for example, val bill amount of type float, and if I only write, for example, 34567, you can clearly see that there is a warning, there is error message. The floating point literals does not conform to the expected type float. And we have a suggestion as well. It says that change it to f. So you should add f at the end. So f can be capital or f can be small as well. So it is very important to add character f at the end to indicate it is float type of value. When we are not adding character f, then it is considered as double type of value. Okay, for example, val discount, it's going to be double type of value equal to, let's say, 12.45. So here you don't have to specify, you don't have to add character f at the end. By default it is double. All right, so this is how we can use this variable, declare this variable. Another important point about type conversion. So all these variables, let it be byte, let it be short, let it be int, then long, float, double, all these data types supports conversion to other data types. Okay, and for that we have some important functions. For example, let's consider we already have a variable. For example, variable is let's say bill amount. Okay, so this bill amount I can convert it to integer. Okay, so b int equal to, for that I have to write bill amount dot to int. I can also convert it to a short type of variable or byte type of variable. Okay, so byte bill, for example, equal to bill dot to byte, bill amount dot to byte. Okay, it is deprecated though. It is also showing as a error using 2 byte is an error, unclear conversion. So 2 int 2 byte. Okay, then you can also convert it to the short one. So short bill equal to bill amount dot to short, or directly short is deprecated, so first you should convert it to the integer and convert it to the short. We have already converted it to the integer. I can also convert it to the long type of value. So any variable can be type converted to any other type. Okay, integer can be converted to the float. For example, we already have one integer variable, for example, what is that, theme color, for example. Okay, so theme color float, there must be a variable to convert it to the float type of value. So float theme color dot to float. You can convert it to the theme color double as well. Double, it is of type double, equal to theme color dot to double. So this type conversion is perfectly possible. Integer, it is also possible for integers. I can convert theme color, if it is of type integer, I can convert it to the long, byte, short, so and so forth. So theme color short, for example, it is going to be a short type of value. So here I will write theme color dot to short. All right, so here you can see theme is a long type of variable, and on this long type of variable I can invoke these functions. So theme color dot to, here you can say to float, to short, to byte, to long, to int. Even it can be converted to a character type of variable, to double. You can convert it to the string as well. Everything can be converted to string. To big decimal, so big decimal is useful to store the very huge number, which is like 200 50 digit number, 60 digit number, so and so forth. We also have option to convert it to the hex string. We also have option to convert it to the unsigned byte, unsigned int, unsigned long, short, so and so forth. So this is how a one variable of particular type can be converted to another type of variable as and when required. Okay. Of course, during this conversion, there could be a loss of value, because let's assume we have a long value which is very huge, for example 700, and if I am trying to convert it to byte, so range of byte is maximum value is 127, so that may not fit into that value. So this is how the conversion can impact to the reduced value. This was all about numeric data types in Kotlin. That's all in this video. Do let me know if you have any doubt. Write it into comment. If you like the video, please like it, subscribe it. Thanks for watching. See you in the next video.